Water is what we look for on other planets when we look for life. It's the medium in which all the atoms and compounds exist for living things on Earth. It also turns out to be a very unique molecule in itself, with properties not seen in other molecules its size. One of the unique properties of water, especially for a molecule its size, is that it's less dense as a solid than a liquid. This means that solid water, ice, floats on liquid water. If water was like most molecules, its solid form would be more dense than its liquid. That would mean that bodies of water would freeze from the bottom up. Our whole planet would be frozen oceans, even at our current position and angle from the sun. Life would not be able to exist as we know it if water was a typical three-atom molecule like acetic acid, for example. This and other physical and chemical properties of water make it well suited to allow life to exist and help with maintaining homeostasis. Let's look more closely at the molecule itself, often represented as the Mickey Mouse model. The most important chemical property of the water molecule, the one that leads to almost all its uniqueness, is its polarity. Because oxygen is a larger atom, contains more protons, it has the electrons of the covalent bond much more than the small hydrogens. This means that the Mickey Mouse head has a bit of a positive charge on it, while the Mickey Mouse chin has a bit of a negative charge on it. Therefore, things with opposite side charges are called polar, and water is a polar molecule. This polarity is an important reason water is especially good at making mixtures, particularly solutions. When ions, such as those from typical salts, get into water, something unusual happens. The ionic bond separates, and the positive ion is attracted to a negative side of a water, while the negative ion is attracted to the positive side of a water. Therefore, in a solution, the ions are still ions, although they are not joined together, but they do maintain their chemical properties. It's a physical change that occurs, not a chemical change. Water is very good at mixing with and making solutions for other polar substances. These mixtures could be solutions, colloids, or suspensions. Just as water uses hydrogen bonding to form solutions with ions, water can form hydrogen bonds with itself. This property is called cohesiveness. It's the reason that water has surface tension, and some insects can walk on water. The ability to stick to itself is cohesion, but the ability to stick to other things is called adhesion. This property of adhesion leads to capillary action. It gives water the ability to climb narrow tubes in plants called xylem. These tubes run throughout even the tallest of plants, but plants don't need a pump to get the fluid distributed in them because of this capillary action. So far, most of the special properties are due to the ability to form hydrogen bonds with itself or other things. Those hydrogen bonds are influenced by the number of free hydrogen ions in a water-based mixture. Therefore, a system has been devised to quantify the amount of hydrogen ions in relationship to the amount of hydroxide ions. This system is called pH. The pH scale is a measure of the ratio of hydrogen ions to hydroxide ions. It is not a measurement of just hydrogen ions, but that is a good way to begin thinking about it. It's a negative logarithmic scale. This means that it only goes to 14, and because it's a logarithmic-based scale, each step on the scale represents a tenfold difference. For example, 6 is 10 times more acidic than 7, and 5 is 100 times more acidic than 7. Because it is a negative logarithmic scale, the lower numbers have more hydrogen ions. That means that low numbers on the scale represents high amounts of hydrogen ions and are therefore acidic. Higher numbers represent lower numbers of hydrogen ions, but higher amounts of hydroxide ions, and are therefore basic. If there were exactly the same number of hydrogen ions as hydroxide ions, the pH is right in the middle at 7, and the solution is neutral. Pure water is an example of a neutral substance. pH is very important for organisms. It allows their enzymes and other proteins to have the correct shape, which are the result of hydrogen bonding within them. That correct shape means the correct functions. So organisms use a system called buffers to maintain homeostasis. Buffers are chemicals that add hydrogen ions when the pH is too high, or hydroxide ions when the pH is too low, in a classic homeostatic mechanism.